The morning of June 28, 1942, began like any other routine patrol over the French coast, yet it would become one of the most consequential days in the study of British air superiority. Pilot Officer Burling Smith of 131 Squadron climbed into his Spitfire Mark VB, serial number AB910, checking every gauge, switch, and control as he prepared for takeoff from RAF Perranporth in Cornwall. The grass runway was slick with dew, the morning sun casting a pale gold light that shimmered across the wing tips, and the Rolls-Royce Merlin hummed steadily beneath him, a deep, confident growl that had guided him through countless missions. 11 other Spitfires lifted in formation, engines synchronized like a mechanical orchestra, rising through scattered clouds and into the open skies above southern England. Intelligence reports suggested minimal Luftwaffe activity, and the pilots expected a routine sortie, a brief encounter with any reconnaissance aircraft that might be patrolling the channel. Yet the skies above France had their own plans. Minutes into the flight, Smith's eyes scanned the horizon as he maintained formation, unaware that a single, swift shadow would soon appear from the brilliant sunlight, altering the course of history for AB 910. Out of the sun came a Focke-Wulf 190, diving at impossible speed, and one shell tore through the engine cowling, sending smoke curling into the cockpit, choking the Merlin into silence. Smith's heart raced as he realized he could not make it back across the 60 miles of open water. Below, the French coastline stretched, fields dotted with villages, German troops moving in formations he had seen from the air countless times before, and in the midst of all this, a single flat field near the village of Creville offered the only chance of survival. Dropping the landing gear, adjusting the nose, and carefully bleeding off airspeed, Smith executed a textbook forced landing. The Spitfire rolled across the damp grass, the propeller bent slightly, the cowling punctured, yet otherwise pristine. Smith scrambled for his incendiary pistol, intending to destroy the aircraft, but German soldiers emerged from the tree line within seconds, rifles aimed, capturing both him and the intact Spitfire in a moment that would change the Luftwaffe's understanding of British aviation forever. Within the hour, Luftwaffe intelligence officers arrived, moving deliberately around AB 910, their eyes tracing the smooth elliptical wings, the precise flush riveting, the semi-monocoque fuselage, and the cockpit untouched. Every officer present recognized the extraordinary opportunity. This was not a wreck, it was a fully intact fighter, capable of being flown again with only minor repairs and an engine replacement. Over the following days, AB 910 was carefully drained of fuel, control cables disconnected, and transported under heavy guard to Recklin's secret test facilities near Lake Müritz, every precaution taken to prevent Allied reconnaissance from discovering the aircraft. Only selected personnel with top security clearance could approach the Spitfire, and armed guards were stationed around the hangar to enforce strict secrecy. The test pilot chosen for the initial evaluation, Hauptmann Rolf Pingel, was a veteran of 26 confirmed victories, an analytical mind as well as a combat-hardened pilot, whose reputation for precision flying and technical understanding made him ideal to assess the captured British aircraft. Standing before AB 910 under harsh electric lights, Pingel marveled at the Spitfire's construction. The elliptical wings, long admired for their aerodynamic efficiency, were flawlessly smooth, each flush rivet meticulously seated, minimizing drag. When placed on calibrated scales with a replacement Merlin 45 engine, the aircraft weighed nearly 300 kilograms less than German intelligence had predicted, translating into superior climb rate, acceleration, and turning performance. Pingel moved to the cockpit, inspecting each control. The layout was logical, the throttle quadrant, trim wheels, and gun sight fell naturally to hand and eye, and the bubble canopy offered panoramic visibility that German pilots could only dream of, providing nearly unobstructed sightlines in all directions except directly aft. Every control surface responded with harmony and lightness, ailerons, elevators, and rudder working together with near-perfect precision. Engineers marveled at the semi-monocoque construction. The stressed skin carried aerodynamic loads, allowing for a lighter yet stronger fuselage. This design approach, long considered too complex for mass production, had been executed flawlessly by British manufacturers. Over the next 3 weeks, German engineers meticulously installed and tested the replacement engine, verifying fuel lines, ignition timing, coolant systems, and propeller operation. German synthetic aviation fuel, slightly lower in octane than British 100-octane petrol, would limit maximum engine performance slightly, but this only made the Spitfire's superiority more striking. Finally, on July 29, the skies over Rechlin cleared, and Pingle climbed into the cockpit for the first test flight. The Merlin roared to life, a sound previously dreaded by Luftwaffe bomber crews, now echoing through German skies in service of its captors. Takeoff was smooth, the Spitfire lifted with little back pressure, climbing easily into the open sky. Pingle tested the controls at 3,000 meters, discovering responsiveness that seemed almost magical. Gentle stick inputs produced immediate and precise reactions, the aircraft rolling, banking, and turning with a speed and smoothness impossible in contemporary German fighters. Vertical maneuvers, loops, and stall tests revealed a machine that handled predictably even at the edges of its performance envelope. The stall was gentle, the aircraft offered ample warning before dropping, recovering instantly with light power adjustments. The roll rate was astonishingly fast, and the tight turning radius confirmed the superiority reported by British pilots. Over the following weeks, AB-910 was compared systematically against frontline German fighters, including Bf-109F4S, Bf-109G variants, and FW-190s. Using timed climbs, measured turning circles, acceleration tests, and mock dogfights with gun cameras recording every engagement, the data was irrefutable. In horizontal turning combat, the Spitfire dominated, the tighter turning radius and precise controls placing German aircraft consistently on the defensive. Even the newer Bf-109G and FW-190s could not fully overcome AB-910's advantages. Each comparison confirmed critical tactical lessons. German manuals were revised to instruct pilots never to engage Spitfires in prolonged horizontal turns. Instead, they emphasized vertical maneuvers, boom and zoom tactics, diving attacks, and immediate disengagement to exploit speed and dive advantages. Tactical doctrine shifted across the Luftwaffe. Pilots learned to fight on their strengths, not the Spitfires. The captured Spitfire influenced engineering priorities as well. German designers were instructed to focus on high-speed performance, climb, and acceleration, rather than attempting to match the Spitfire in turning combat. This approach shaped aircraft like later Bf-109K variants and the Ta-152, optimized for high-altitude interception. Test flights continued through August, with multiple pilots, each with combat experience, rotating through AB-910 and German fighters, confirming consistent findings. 27835. Rolf Pingle documented every aspect, detailing climb rates, roll performance, stall behavior, control harmony, and aerodynamic efficiency. The results shocked the Luftwaffe. The captured Spitfire was lighter, faster, more agile, and more forgiving than any German aircraft in service, with only maximum altitude speed above 6,000 meters slightly favoring the Bf-109 in specific regimes. Gun camera footage from mock engagements illustrated the Spitfire consistently outmaneuvering German aircraft, validating pilot reports and demonstrating the danger of prior assumptions. The meticulous data forced a complete re-evaluation of air combat strategy, from pilot training to operational planning. Training programs shifted away from turning dogfights against Spitfires, emphasizing altitude management, energy tactics, and disciplined vertical maneuvers. The aircraft's engineering also revealed subtle advantages in control forces and aerodynamic efficiency. Ailerons, elevators, and rudder operated in perfect balance, creating a responsive machine that obeyed pilot intent almost instinctively. Even at high speed, the aircraft maintained control harmony, whereas German aircraft required significant physical input to manage similar maneuvers. The cockpit's ergonomics and visibility were equally impressive. The bubble canopy offered nearly unrestricted sightlines, allowing pilots to detect threats and position themselves advantageously. Structural observations revealed stressed skin construction, superior aerodynamic surface smoothness, and weight distribution that exceeded Luftwaffe estimates, providing superior climb rates and maneuverability. AB-910's testing also informed German intelligence about the ongoing evolution of British aircraft. Reports warned that the Mark VB was likely a mid-range variant. British engineers were continuously developing improved engines, refined aerodynamics, and enhanced armament, suggesting that even greater performance would soon emerge. The captured aircraft thus became a benchmark, forcing both immediate tactical revisions and long-term strategic planning. German fighter doctrine shifted significantly, emphasizing altitude advantage, energy management, and vertical engagements, while deprioritizing turning dogfights where Spitfires excelled. The operational impact was substantial. Luftwaffe pilots who had previously relied on assumptions about Spitfire capabilities were now confronted with empirical evidence that contradicted their experiences, forcing a psychological adjustment as well as a technical one. AB-910's presence reshaped both the theory and practice of aerial combat for the Luftwaffe. The captured Spitfire remained a symbol of British ingenuity, a testament to meticulous engineering, advanced aerodynamic design, and intelligent integration of pilot and machine. Its elliptical wings, light yet strong fuselage, precise controls, and responsive Merlin engine represented a synthesis of form and function that German engineers recognized as exceptional. Every sortie flown in the testing program reinforced the lessons. In maneuverability, handling, climb, and pilot-centered design, the Spitfire was unmatched. The aircraft also served as a reminder that innovation and quality production could not be underestimated, even under wartime constraints. While German engineers meticulously studied every rivet, panel, and system, they understood that the intangible combination of design philosophy and execution gave the Spitfire an edge that raw numbers could not fully convey. As the months passed, AB-910 remained in Recklin's hangar, a carefully guarded asset, with each flight, report, and analysis reinforcing its value. The data gathered informed not only tactical adjustments but also future aircraft development and strategic planning, highlighting the interplay between engineering excellence and battlefield effectiveness. For Burling Smith, interned in a POW camp far from the skies he once ruled, AB-910's capture was a bitter moment, yet the aircraft's continued existence and the intense study it inspired underscored the respect and fear it commanded. The Spitfire AB-910 had rewritten the rules for aerial combat, offering the Luftwaffe a complete and precise understanding of the capabilities they had long underestimated. It forced a rethinking of doctrines, designs, and tactical decisions, illustrating how a single aircraft, preserved intact and examined with rigor, could alter the trajectory of air warfare. Every engineer, pilot, and officer involved recognized that they were in the presence of exceptional design, and that no matter the adjustments made, the British had created a fighter whose combination of agility, speed, control harmony, visibility, and structural ingenuity remained unmatched. It was more than a machine. It was a flying lesson in innovation, a testament to the principle that careful design, precise execution, and understanding of the pilot's needs could create an instrument of war that dominated in ways mere numbers or theory could not predict. AB-910 became a silent instructor in the skies and hangars of Rechlin, a benchmark for all German aircraft to come, and a symbol of the enduring edge Britain maintained in the art and science of fighter design. Its lessons reshaped air combat for the remainder of the war, reminding everyone who studied it that true superiority lay not just in firepower, speed, or armor, but in the seamless integration of pilot and machine, a principle the Luftwaffe would respect even